Hello everyone, thanks for your appearance. I'm Chen, and today I'm going to present our work, DIComP, a method to infer the compiler provenance of strip binaries with the only information provided by its own. Nowadays, many research works successfully apply machine learning method to help improving the effectiveness on some security tasks, such as leveraging deep learning network to infer the function boundary of stripped binaries, measure the similarity of different binaries via novel embedding methods, even translating binary code to source code to each other inspired by the machine translation methods. However, the majority works try to augment the training data to make sure the model can cover as much diverse binaries as possible to have a better performance. According to the observation from the pre-investigation, we hold that the binary's appearance, that is, the initial state of the binary code, is determined by both the program itself and the compilation options together. Neglecting the impact of the compiler may impede the effectiveness of the all above works. To this end, we thoroughly investigate how the compilation options influence the binary's appearance and try to decompose the influence of compilation options and its semantics. To motivate our work, we try to start with 3 examples related to our research works. Binary similarity analysis aims to measure the similarity between pairs of binaries. A precise similarity measurement can bring better detection results. Here we experiment with the widely used similarity measurement tool, BinDiff. As shown in the figure, we cross-compare the binaries compiled from libxml with 25 different combinations of compilation options. That is, 5 versions of GCC multiplies 5 optimization levels. Figure A presents the overall result, and Figure B elaborates the result in the same compiler version. The darker the grids, the more similar they are, and vice versa. It shows that the optimization level has a great impact on the binary similarity comparison, while the versions has less influence. Second, we focus on the task of inferring the variable type from stripped binaries. Type inference aims to reconstruct the binary's variables types from the binary code, which is a requirement of reverse engineering. Existing type inference efforts do not take into account the impact of the compilation options, and we find that ignoring the compiling's impact can affect the inference result. We assume that if we know the compilation options, we can achieve better inference results. With the help of previous work, Katie, we evaluate how the type inference benefit from when we knowing the compilation options, result of which is shown in the table. The results show that knowing the compilation options can improve the inference accuracy by 66.5%. In the real world, these vulnerabilities could lead to many neutral cyber attacks, and we leverage vulnerability reproduction as the last example. Vulnerability reproduction is the first step to diagnose program failure. However, current works show that reproduction is challenging because of the lack of vital building configurations to perform the compilation. Some vulnerabilities can only be reproduced by enabling some specific configurations during compilation. Reproduction of this kind of vulnerability contains 3 steps: compilation option inference, configuration inference, locating vulnerability. Our tool dramatically compresses the search space of compilation options combination, which saves time for compilation option inference. On average, it helps saving half of the processing time. To verify the hypothesis on binary appearance, we create a comprehensive dataset from several open-source software projects. Over 28,000 binaries in total, including OS tools, network programs, etc. The figure presents the mnemonic and register distribution divided by the granularity of compiler, optimization level, and compiler version. As we can see, different compilers indeed have quite different habits on utilizing instructions to accomplish the functionality, while optimization levels and versions contribute to less difference. We list the mnemonics and register distribution of different compilers of which frequency of appearance is in the top 5, which is on the left side, and which have the most different distribution on the right side between GCC and Clown. For example, 36.95% for move indicates that mnemonic move represents 36.95% of all the mnemonics which are collected from the binaries in the dataset compiled from GCC. The result via statistical methods reveal the difference more clearly. Although the distribution of mnemonics between GCC and Clown is slightly different in the figure, we can still mine the influence of compiler from the data listed in the table. We also conduct an empirical study on how the binaries expand after being compiled with different compilation options. The expansion rate mentioned here denotes lines of assembly code divided by the lines of the source code. Due to the different optimization options, the lower levels have larger expansion rates, which also provide a profile for the compilation option's provenance. To dive into the expansion rate, we conduct analysis and statistics on average function length for a more fine-grained way. It has a similar trend as expansion rate, also provide one more feature for us to infer the compilation provenance. According to the relations of different optimization levels, they should contribute to the different on binary appearance. We study and discuss the influence of them in detail, and the relevant information can be found in our paper. After we thoroughly investigation, we leverage the distribution of mnemonics, registers, and function lengths to set up a machine learning model for inferring the compilation provenance of stripped binaries, that is, compiler optimization levels and compiler version. To make it more precisely, we design a hierarchical model to infer the information level by level. And based on our original intention, we want this to assist the security analysis for further research. So we want it efficient, precise, and lightweight. To meet this end, we choose multiple layer perceptron as our base model after comparing with other machine learning methods. As for the evaluation, no matter we use the distribution of mnemonics or register, we can fully recognize the compiler provenance of all stripped binaries in testing set and beat all the previous works. Based on intuition, optimization levels are much harder to be distinguished than compiler via raw data of stripped binaries. So we tried to all the combinations of mnemonics, registers, and function length distribution. We find that when we leverage all the features that we can hold, and we achieve the state-of-the-art result to distinguish the optimization levels of GCC. As for Clown, due to the high similarity of O2 and O3, even the contribution of function length may mislead the result. So combination of mnemonics and registers achieve the best result. For comparison, we present a confusion matrix for classifying the optimization levels. The left one is for GCC, the right one is for Clown. As we can see, Clown are much harder for us to distinguish the optimization levels, especially between O2 and O3. And for compiler version, which is much more fine-grained in this task, it is still hard for us to distinguish it successfully, and we will make it as our future work. At the end of the evaluation, we make an efficiency comparison to meet the two design for binary pre-diagnose. According to the table, no matter the time-consuming or model size, we have the best performance among all the learning-based methods from now on. At the end of the presentation, I will conclude our work in brief. We comprehensively study how the different compilation options influence the appearance of binaries in terms of mnemonics, register, and function length. And second, we design and implement a lightweight and efficient system called DIComP, which can infer the provenance of compiler and optimization level. And the last one, we accomplish a comprehensive evaluation of a wide range of applications, and the result shows great performance on accuracy and also processing speed. And thanks for your listening. Here is Q&A time.